Let's work a problem here. So we're going to find any points on the line y equal x plus 1 that are 2 units away from the point 1, 4. All right, well, let's draw a picture just to kind of remember what these things are, right? We want a point on this line, so let's draw a picture of that line. We know that it's a, well, we're told that it's a line, and we know that it's a line because of the form of it, right? We have the slope here, so that's 1. Have the y-intercept, that's also 1. There's your y-intercept, and if I want more points on the line, I can just go up 1 over 1, up 1 over 1, la-di-da. Or left 1, down 1, if we want to do that. So anyway, here's the nice picture of our line. Let's pretend I went through that point. Okay, so we want to be 2 units away on the line. We want to be on the line and 2 units away from the point 1, 4. So 1, and then 1, 2, 3, 4 would be here. So I want to be 2 units away. So I don't know, did I just draw those? Who knows? I mean, maybe I did. But the idea is that we want the distance here to be 2, and it kind of looks like that's 2. And then we want that one to be 2 as well. So we want both of those things to be 2, right? This is the point 1, 4. Well, I mean, the picture suggests that it's the point 1, 2, and hey, maybe it is. But we need to go and show that that's true. And the picture sure does look like it's 2, 3. It sure does, but we need to go show that that's true, because it's not always going to work out super conveniently for you like that. I mean, maybe it will, but in general, it probably won't. This is the line y equal x plus 1, right? So we can say, well, find any points on the line y equal x plus 1 that are 2 units away from the point 1, 4. So this is kind of where we slip up. Like, maybe we can draw the picture and we kind of have an idea what we're looking for, but now we don't know what to do. Well, here's where we kind of, I mean, there's a tiny bit of creativity, I guess, involved here. We're just going to say that we have the point. Like, if I had the point and I told you that it was xy, I could say that that's such a point, right? So let's say xy is on the line, also 2 units from the point 1, 4, right? Okay, so we have it, say it's xy. Well, now we can kind of start working with this. Once we give ourselves a name the object that we want, we kind of somehow have more, leverage or more power over it or whatever. So we gave it a name, call it xy, it's on the line. Well, what does that mean? So if it's on the line, that would mean that I'd plug it in and it'd make it true. So if I put this x right here, this y right here, that's true. So y, I put that right there. Well, y is x plus 1, right? If I gave you the x value, you'd plug that in there and you'd know what y was, right? So if we take that x value, say it was 1, I would put a 1 in there and say, okay, 1 plus 1 is 2, that's the y value. So if I have the point xy on the line, xy must look like x comma and then x plus 1, right? Because no matter what, if I give you an x value, you're just going to plug in x plus 1 to get a y value. So that's what that point must look like, right? So now we can just use the distance formula. If this number is, if that point is 2 units from 1, 4, we can use the distance formula now, right? So distance from x comma x plus 1 to 1, 4 is 2. So we can take this nice statement in English and we can use the distance formula to write what has to be true here, right? So maybe we can remind ourselves what the distance formula was, right? Distance was x sub 1 minus x sub 0, and the difference in the y values. So we just have to assign now subscripts to these. And it doesn't exactly matter which one you call x sub 0, y sub 0, which one you call x sub 1, y sub 1. It doesn't matter as long as you're consistent with your ordered pairs. So we're just going to plug in what we've got, right? So let me call, let's call this x sub 1, y sub 1. And let's call this x sub 0, y sub 0. All right, so we're just going to plug these things in there, right? That's going to be our d. So we got 2 equals that junk. So I got square root of x sub 1, so that's x, minus x sub 0, that's 1, plus y sub 1, that's this one, minus y sub 0, so that's this one, so minus 4. All right, so now we have an equation that involves x, and I can solve for that x value. So this, the solution to this is going to tell me what my ordered pair is, because I'm going to find this solution and just plug it into the nice equation to find the corresponding y value of the point on the line. All right. So anyway, we can solve the nice equation involving x here. So our steps here, we would probably want to square this, square both sides to get rid of the radical, and we can do that, right? 2 squared, that's 4, and then we have that just gets rid of our radical. And why don't we combine that too? So this is x minus 1 x plus 1 minus 4, so that's x minus 3 squared. Okay, so we've got, whoops, I was off there for the whole time. So we have general equation solving strategies for quadratics, and maybe we won't talk about those too much. We're just going to multiply everything out and get everything on one side. So we got 4 is x squared minus 2x plus 1, right? Squaring the binomial, we get this. Square this binomial. Be careful here too. We want to have grouping symbols so we preserve whatever sign action is going on. So we've got x squared minus 2 times the product there is 6, and then that number squared. Okay, so we want to get everything on one side, sort of drifting to the right there. So we want to subtract 4 from both sides and combine all of these. So we got x squared plus x squared, that's 2x squared. What else? So we got minus 2x here. We've got minus 6x there, so we got minus 8x. Okay, 1 plus 9 is 10, minus 4 would be 6. Okay, and now we can probably make our lives easier by just multiplying everything by a half, right? So a half times 0 is 0, and then we got x squared minus 4x plus 3. Okay, so we're still trying to solve this guy. And our strategy there is to factor, right? So we've got 3. We want to find 2 factors of 3 that add to be negative 4. So we've got, what, negative 1 and negative 3. Okay, so that tells us that x is 1 or x equals 3. So our points are x, comma, and then the x value that goes with it, or excuse me, the y value that goes with it. So remember, the line is y equal x plus 1. So this is where we're getting our points, right? So we're plopping them in here because we know that these lines are on the, whoops, 1 comma, and then I would put that in here, right? X being 1, y would be 2, and then, and our other one would be x equal 3, and then that would be 4. Okay, so we found these points, 1, 2, and 3, 4. So did that agree with what we said at the beginning? 1, 2, and 3, 4. I mean, kinda. It looks like that one's there, right? 1, 2. This one might be a little off, maybe just because my scale's off, but it's, you know, it's kind of reasonable, right? It'd be there. And you know, the line was slanting down, I don't know. But yeah, we found this analytically. We found, you know, we could draw the picture, and that's absolutely true that sometimes the picture will turn out to give you the right point. But it only, you know, our observation looks like it only gave us one of the correct points. So be careful with trusting what you've drawn. Anyway, we found the points, and I think the hard part was probably keeping everything straight, maybe in solving that quadratic equation. But I don't know. Solving quadratic equations isn't exactly a point. If I were to point to a difficulty, it would probably be when we switched from using words to using math stuff. And maybe in particular this thing. Like we wanted to say what a general point on the line looks like so that we could start, manipulating it, and we can use the nice distance formula. This is kind of like what I'm asking you to do for that problem on the worksheet. Kind of like this, but it's not exactly the same. But the idea is pretty similar. So maybe draw yourself a picture for that one and think about what's going on with that. Anyway, have a great weekend.